Hello and welcome to CircuitShepherd. In this video, we'll investigate how to design non-inverting operational amplifier circuits with CircuitShepherd. While we've already met the most simple version of these circuits in a previous video, we'll go a step further now and show how to define and synthesize any completely arbitrary, non-inverting linear transfer function for gains greater than 1, including a DC offset, and also provide the AC gain with a well-defined bandwidth limit. Let's start with the most simple version of the non-inverting operational amplifier circuit and plot the DC transfer function. While the voltage gain is defined by the proportion of R1 to R2, we can add a voltage source in series to R2 to add an offset to the DC transfer function. To inspect the AC transfer characteristics, we can copy the DC sweep plot and switch to Bode plot mode. Note that the maximum bandwidth of the circuit is limited by the gain bandwidth product of the operational amplifier. A professional design will always ensure a well-defined bandwidth limit, just high enough as needed, which can be achieved by adding a capacitor in parallel to R1. Let's set up auto parts and design targets which clearly define the transfer characteristics in the DC domain. We use the LF mode to measure the small signal gain, which is independent from the offset of the DC transfer curve. To define a certain offset, we add a DC sweep target. We get rid of the virtual reference voltage V2 by utilizing Thevenin's theorem to substitute V2 and R2 with a voltage divider. If needed, for example for bias current compensation, the inner resistance of this network can be well defined with a little entangled helper circuit. At last, we take care to get a certain bandwidth limit for our circuit. Since the Bode plot shows an ambiguous phase curve, we are forced to use a gain design target to define a bandwidth limit. Alright, since we are done now, let's give 2 more hints for the finish regarding to the Thevenin substitutions we have done in this and the previous video. So there is normally no need to firstly introduce a virtual voltage source, which is then substituted by a voltage divider anyway. While this method is essential for manual circuit design calculation, it's mostly obsolete when you use CircuitShepherd. However, sometimes it can be helpful to do it anyway as an intermediate step to get a better understanding of the circuit. For example, by doing so, we have the opportunity to verify if the required reference voltage lies between the available supply voltages. This, of course, is required for being synthesizable by a voltage divider. Finally, as an important fact, it should be mentioned that the temporary reference voltage we have used to introduce an offset always equals the point where the DC transfer curve crosses the first median. Or in other words, if the input voltage equals the output voltage, then the input voltage also equals the required reference voltage. This is true for both the non-inverting and inverting operational amplifier circuit. Stay tuned for more in the next videos. Thanks for watching. See you later.